Okay, so I'm going to walk through the 3 different ways of identifying a model in both Lavaan and MPlus and show that you get the same model fit and the same model implied variance covariance matrix either way. It just kind of changes how you interpret the parameters, because when we set a scale, like we mentioned before, something has to equal 1 in the variance. And when we get to the intercepts, something has to equal 0. So I'll show you where those are. Like I mentioned at the start of the break, all of my examples are in a folder in the Dropbox called Zack's examples. So you're welcome to run these and look at these if you like. So I'm working with the AAM DAT, Agency Achievement and Motivation. It's an example I worked up. It has 3 indicators each for 3 latent constructs, measured in a 5-point scale. Now, by default, Lavaan and MPlus, like I mentioned, will use marker method. So I will just define my model without any added parameters. And I'll just run a default CFA on it. And we'll look at the summary. I'll get my model fit up here. And I can see in my output that those first loadings are fixed to 1. So marker method, my 1 is placed on those first loadings. And the 0 I mentioned before is placed at the latent level when we get to the mean effects. And I see down here in my variance section that my latent variance is being estimated. But since this is the marker method, this variance is the reliable variance of my first indicator. So if I take this variance plus the residual variance, I'll get the total variance for that first indicator. I'll demonstrate that in a second. But we can look at our model implied variance covariance matrix. So I have all my items, variances and covariances, as calculated or as defined by my model. And I have my model implied means. And what we're doing essentially is we're taking our model implied variance covariance matrix and we're seeing how close it is to the actual observed variance covariance matrix. And that's where we get our model fit. Going back to that marker method, the actual observed variance of my first indicator is 0.38130. And now I can add that first variant, or the latent variance of agency, and the residual variance of agency, and the close. Grab our parameters. And 10. Yep. Now we move on to fixed factor. We're taking that 1 and 0 and placing it at the latent level. So our latent variance will be fixed to 1 and our latent mean will be fixed to 0. And in Lavaan, the only thing you have to change is adding this argument right here. std.lv, standardized latent variance, equals true. Need to define my model. And I see that these loadings are now being estimated. My model fit is the exact same as it was before. But now I have latent means at 0 and latent variances at 1. So now I have a standardized normal distribution as my latent variable. And my model implied variance covariance matrix is the exact same. So I've just shifted where those ones and zeros are, but everything calculated out to be the same. Now, effects coding is a bit more involved because it involves labels. So we put a label at each of our loadings. I use L for either loading or lambda, but you can use whatever convention makes sense to you, as long as it starts with a letter. And then I'm freely estimating my latent variance. I'm freely estimating my latent mean. And then I put labels on my measured intercepts here. I use T for tau, but again, you can use whatever you want. And then here are those model constraints that we were talking about. So I have L11 equals 3 minus my other two loadings from up here. So that makes these average 1. And the intercepts, the 0 is the average of the measured intercepts. So these will average 0. So I see I have estimated loadings that average 1 for each one of my latent constructs. My model fit is the exact same as it was before. I now have estimated latent variances or latent intercepts. So these are my latent means. And I have estimated my latent variances down here.
So can I just, before you scroll further, Zach,
Yeah.
highlight that those latent means for the first time, rather than being zeros, those are in the metric of the 1 to 5 scales that people responded to on those items.
Yep. And this is why effects coding is so handy. You actually get back that information.
So does the including the mean structure change anything to the model fit? I don't think, right?
It doesn't, because you're estimating as many parameters as you're providing. So it's not, you're not asking for any more information.
So and for the model constraints part, you have to constrain the intercept. So the intercept has to add up to be 0.
Yes, you can see that right here, the measured intercepts. So basically when you tell the model that these will average 0, you're forcing that main information up into the latent space. So that's why I have means of my latent constructs, because I've told them that my measured means average 0.
Okay,
so basically get a weighted average based on my loadings.
So you don't have to do this constraints for the intercepts if you do the constraint variance to be 1 method.
For fixed factor, you don't have to do any model constraints. It's just your basic model, and it automatically puts those variances or those intercepts at 0. And I see my measured intercepts are in the original metric. And we can look at that model implied variance covariance matrix is again the exact same as it was before. Now recently, oh, go ahead.
Sorry, I just wanted to highlight this for folks. If they haven't used Lavaan before, Lavaan is case sensitive. So for example, if you look at the constraints that Zack used, he's got capital L's and capital T's. And especially with the L, it's very helpful to have a capital L so that you're not confused about, was it a lowercase L or a capital I that was being used? And if he had used a lowercase L by accident somewhere, it would not run. It would come up with an error.
Unknown label. So yeah, Lavaan is case sensitive, but it's not space sensitive. I can put as many spaces in here as I want. That's fine. But it is very case sensitive. So if you have agent instead of lowercase agent, it'll tell you that variable is not on my data set.
I've had a student become frustrated between the difference of an O and a 0 with their variable name. So it's just important to look out for those things as a common typo issue.
Yeah. If you ever see this, it typically means typo, missing observed variables in data set, saying that whatever you named it is not finding it on your list of data set names. Now, Lavaan has recently added an effects coding argument, kind of like the standardized latent variable argument here. So you don't have to go through and do all the labels. So a regular model, I just have effect.coding equals true here. And it's the same output. Variance is estimated. Latent intercepts estimated in the metric of my measured items. Same model fit, same degrees of freedom. I still prefer doing it this way because when we move on to other kinds of modeling, the labels do come in handy. Now for MPlus.
Sorry, one more thing before you switch to MPlus. Just wanted to highlight in Zack's syntax, you also see how he's specifying the missing and the estimator to use so that it's a FIML approach that's handling his missing data. Just because that's very useful, but sometimes hard to find in the syntax.
Yeah. And lucky for me, this has no missing data, but if I did, that would take care of it. And my missing data example, I poke holes in this, so that one does. Any questions about Lavaan before I move on to MPlus?
Can I ask a quick question?
Yeah.
Because PCOX was brought up, because like doing the FIML without using the auxiliary components was wrong, right? Like so just having the missing the equal to FIML is not sufficient. So we have to call in the auxiliaries.
Yes, FIML will only use the variables that are listed in your model or are listed as auxiliary variables. So over in my missing data method comparison script, which is also in that folder, I have a section down here where the package SimTools lets you run a CFA with auxiliary variables, and you list your auxiliaries here. If you're running in MPlus, it would be auxiliaries are list variables.
Okay, and the variables are those generated by PCOX?
Yeah, they can be the physical components, or if you know some specific variables that may be informative of the missing. I just have age in here as an example. But if you don't have auxiliary, if you don't have principal component auxiliary variables, you just have variables in your data set you want included as being informative of that missing data pattern, you can list them here.
Okay, so that means is it actually wrong to use Lavaan to do the FIML because it does not allow you to include the auxiliary, and you have more variables in your data that are not in the model, so they're not used to impute the missing.
If your model captures all of the possible information regarding the missingness, then base Lavaan would be sufficient, but that's typically not the case. But this runs Lavaan, it just includes auxiliaries as part of the argument. So CFA.auxiliary, SimTools calls Lavaan. So I'll get,
I see.
Yeah.
So here you put all your variables in your data that are not in the model as auxiliary.
it didn't necessarily have to be all of them, but all of them that you think would be informative of that missing pattern. If you put
Okay.
all of your variables in here, then this could kind of be a hard model to estimate,
I see.
which is why multiple imputation is good for those kind of cases. You can then use all of your variables in your data set to inform the probable values of those missing observations.
Yeah, if you just as a general rule, if you have a lot of auxiliary variables that are going to be used in a FIML analysis, it can become difficult for the software program just to complete the process. So that's part of why we also talk about multiple imputation, because then you can utilize all the variables in your data set plus the auxiliaries to inform that process and not overwhelm the modeling process, because you separate them into two different steps.
That's exactly right.
Okay, now MPlus. We'll start with marker method, the default method. If you've seen MPlus before, you have your title section, you can call it whatever you want. Data tells it what file you're picking from. If your input file is saved where your data file is, you don't need to specify a path. You can just tell it what the file name is. You have to list all of the variables in your data set in order. Very important that it's in order, because MPlus assumes your names are in order, because MPlus doesn't want a data set with names on it. So the data for MPlus can't have column names. You specify your column names here. And then if you're only using a subset of those, you then have to say use variables are, and then the variables you're actually including in your model. I have my estimator as maximum likelihood. And then I have my model statement, which is the exact same model statement we had before, just in MPlus language. I'll run that. We'll get the same fit as we got with Lavaan. So here is my model fit information. And I see that those first variables are fixed to 1. That's MPlus's default as well. It doesn't list the latent means, but they're also fixed to 0. And then one thing I should note, if you're getting standardized output, Lavaan puts that on the very last column over here. MPlus stacks your standardized output. So you have your unstandardized first, and then you have your standardized if you request it. To do fixed factor, where that latent variance is fixed to 1, we have to free up the first loading by putting a star. This tells MPlus, please estimate this first loading, please. And then we have to apply these constraints. So if you just list the latent constructs, I have agency at 1. This tells it to fix that variance to 1 for each of my latent constructs. And don't forget the semicolon. And then means is in brackets. So agency at 0 fixes my latent agency mean to 0. So no quick and easy argument for MPlus. You just have to specify with model constraints. But we get the same model fit. I see my first loadings are being estimated. I now have a means section for my latent means, which are 0. And my variances are fixed to 1, like I asked.
And so that means that at the latent level, you are estimating it in standardized metric, right? A mean of 0, with your standard deviation and your variance at 1. Just to reinforce and connect those pieces.
And then for effects coding, we're back to labels. So I still have the same labels I had before. L11, L12, L13, 2.1, and 3.1 down here. I'm now freely estimating my latent variance, freely estimating my latent mean, and I'm labeling my item intercepts like I did in Lavaan. But we're back to using the brackets. Brackets work for both latent and manifest intercepts. And then I have my model constraint statement down here at the bottom, where I make my loadings average 1 and my intercepts average 0. And like Whitney mentioned before, if you have more than 3 loadings, say I had a 4th, L14, this becomes a 4. I'll run that, get the same model fit, because again, we're just changing where we put those 1s and 0s. They're going in our model somewhere. We're just choosing where they go. These will average 1. Now my means, my latent means are in the metric of my measured variables. And so are my variances. And my intercepts here will average 0 because that is my model constraint. Any question about model identification in either MPlus or Lavaan?
My question is, do we have to specify the mean structure? Like, if we don't constrain the mean, don't let the latent means be estimated, does it matter to the model?
With marker method and effects or fixed factor, especially with Lavaan, since it does it automatically, whether you ask for the mean structure or not, you won't need to specify it. I'm not sure about effects coding because I always work with the mean structure too.
Well, and it is possible to estimate an SAM model without the mean structure.
Mm-hmm.
That was, especially if you read papers that are older, that was sometimes a limitation from a computational perspective of just the total number of parameters to be estimated. People would sometimes drop out the mean structure to be able to focus on the relationships between the constructs that they were interested in and be able to estimate the complex models they wanted to. They'd sometimes take out the mean structures. But we tend to bring them in and leave them in unless we run into a calculation issue, which is less common now.
And if you run Lavaan's effects coding without the mean structure argument, it still gives you the mean structure. So, and effects coding does focus on getting out your latent mean and latent variance in the metric that you measured it in. So that could be why it chooses to include these automatically. But if I took out mean structure from, say, fixed factor, still gives it here too. So I guess Lavaan wants to estimate it, whether you ask for it or not.
One other thing to also just reemphasize is that regardless of the approach you take, you want to use the same approach for both your mean structure and for your variance covariance structure. So if you're saying your variances to 1, so you're going with the fixed factor approach, then the means for the latent construct should also be set to 0 to be consistent. If you're going with effects coding, then you want to do that for both the loadings and for the item intercepts or means, so that you're consistently estimating everything in the same way for interpretation purposes. So you don't want to be mixing and matching the ways you're doing your identification.
If you set mean structure to false and take out femal estimation, it will just do the variances without the mean structure. But using femalizer estimator or femalizer missing data estimator, it forces mean structure to be true. You want to talk a little more about mean structures?
Yeah, I was just gonna, any other last questions at this point for Zach? You're allowed to ask him questions again later, but from this demonstration, any other questions?
And again, this example script is in the Dropbox folder.
All right, let me just get my controls back here.
For both MPlus and Lavaan. Also, the output is in the folder as well, and you can read MPlus input and output files with Notepad or any other plain text editor. So even if you don't have MPlus, you can still look at the input and output files.
I have a question. So I kind of observed, okay, like comparing the different approaches, like fixing the unit loading identification versus the variance to be 1. For like a single group model, the fit is the same, but sometimes for multi-group, say doing a measurement in variance, I think the results change, because if you do the matrix variance, have to fix equal loadings for the first indicator. Just empirically, the model fit could be worse with the approach when you fix the variance to be 1. Have you seen that?
The model fit, even for doing multiple groups, still doesn't change depending on how you identify the model. When you fix the variances, like in weakened variance, to be equal to the first group, you relax the constraint on the latent variance in this other groups. So they are no longer fixed to 1, just your reference group keeps that constraint.
Oh, I see.
And we're going to walk through how to do the measurement and variance across time and group in the next couple days to reinforce some of those differences depending on how you identify your latent construct. So which scale setting approach you take influences a little bit of your approach as far as what's being freed or fixed. And we'll go through all of that to make sure you're comfortable with that. And you'll have example syntax as well.
Got you. Thank you so much. I mean, that's a perfect answer to my question.
So now